Hello, men and women of science. This is Mr. Cochran here to talk about why learn about acids? Because they're one of the most important industrial chemicals used today. Why are acids used so extensively? Because they are so reactive and the reactions can be spectacular. Just look at what a few drops of acid do to this volatile mixture. It's awesome, baby! Acids are all around us and within us. Ever have an acid stomach? It literally is. Your stomach can secrete hydrochloric acid in concentrations strong enough to burn a hole in a rug. Before we examine properties and reactions of acids, let's take a moment and review the structure of a typical acid. Acids tend to have the general formula HX, where H represents one or more hydrogen cations and X is some sort of negative anion. Typical acids include hydrochloric acid, sulfuric acid, and phosphoric acid. As you can see, all have hydrogen ions bonded to the anions chloride, sulfate, and phosphate respectively. You'll almost always encounter acids in aqueous solution. That's to say that acids are usually dissolved in water where they dissociate to form protons that quickly associate with water to form hydronium ions. When working with acids in solution, we consider hydronium ions and protons to be one and the same. You already have a great deal of experience with one property of acids. Acids have a sour taste. Citrus fruits, for example, contain citric acid. Safety note, never ever taste anything in a chemistry class. It could be fatal. Have you ever heard of the litmus test? One of the earliest recognized properties of an acid is that it turns litmus red. Here you can see blue litmus paper changing to red in dilute HCl. Bases, on the other hand, turn red litmus blue. You've all heard of the pH scale. It runs from 0 to 14. Acidic solutions have pHs below 7. Basic solutions, also called alkaline solutions, have pHs greater than 7. Neutral solutions have a pH of 7, but we'll talk about pH another time. Speaking of neutral, let's take a moment to look at one of the typical reactions of acids, neutralization. Neutralization reactions are double replacement reactions between an acid and a base. The products of this reaction are usually a salt and water. This demonstration shows equal moles of HCl and NaOH being added together. Can you name the products? You can see from the litmus test that the product solution is neither acidic nor basic. It's neutral, hence the name neutralization. Active metals, those with activities greater than hydrogen in acids, will undergo a single replacement reaction with acids to produce a salt of the metal and hydrogen gas. To demonstrate this property, we'll take advantage of the reactive metal found in the center of all pennies made after 1982, zinc. Here's a shot of the zinc metal that fell from the penny. A small hole piercing the thin copper skin just below Lincoln's nose allows hydrochloric acid to react with the zinc inside. Bubbles of hydrogen gas can be seen coming from Lincoln's nose. The zinc inside dissolves in solution as the salt zinc chloride, creating a void in the penny. The hydrogen gas produced from such a reaction is quite flammable. Here we'll ignite the hydrogen gas collected from the reaction between magnesium metal and hydrochloric acid. Acids will also react with substances known as carbonates. This limestone carving, made up mostly of calcium carbonate, shows acid rain damage. Here's what happens. A neutralization reaction occurs, but there is more going on. When the hydrogen cation from the acid reacts with the carbonate ion, it decomposes to produce carbon dioxide gas and water along with the salt of the cation from the carbonate and the anion from the acid. Here you can see the familiar results of the reaction between sodium bicarbonate, baking soda, and acetic acid found in vinegar. This produces salt, water, and carbon dioxide gas, which is released into the tank. As carbon dioxide is more dense than air, it remains at the bottom of the tank. These soap bubbles are floating on an invisible layer of carbon dioxide. We're able to scoop CO2 from the bottom of this tank. As the CO2 is more dense than air, it can be poured over the top of the candles, snuffing them out. Well, I hope you've enjoyed this video on acids! Intro music was Heavy by Collective Soul from their Dosage album. Video images brought to you by Microsoft Encarta Encyclopedia. Sound effects by Absolute Sound Effects Archive at grsites.com/sounds. Closing music was screened by Collective Soul from Hints and Allegations. This has been a video by Chris Cochran. So long, men and women of science.